All right, hello grade 9s. Here we go. I'm not going to waste too much time at the beginning, but I want to do a quick little fill in the blank thing here. I encourage you to pause it and try to figure out the answer to number 1. All right, here we go. To create a linear equation, we need two things. So you can't obviously buy any vowels first, so I'm going to put an N here. And I want you to try to guess as I go. This is an L. T, L, whoa, that's a very different L than the other one, I'll change that, and a V. Okay, so that's all the consonants. Now I'll put in the I's, I, A's, E's, U's. We need the initial value. That's the starting point. You'll sometimes hear me call it the y-intercept by mistake. That's because next year that's what we're going to call it, and in different classes I call it that right now, so sometimes I get a little mixed up, especially when I don't see people in front of me. Sometimes I sort of forget which lesson I'm doing, because a lot of this stuff is similar and a lot of it repeats, and you'll find that more and more as you move forward. So we need the initial value. We need one other thing. Try and figure out what this is, maybe pause, think about it. Here we go. S, L, T, F, H, P, R, O, G, N, E, C, A, E, O, E. The slope, or the rate of change. So how fast this thing goes up or how fast it goes down. Let's jump right into it. You are going to find nothing today is new. It's probably the third day of the same stuff. So if you didn't get it the first couple of days, I'm hoping you get it today. So here we go. Let's make equations. An electrician charges $100 just to come to your house, plus $30 for each hour. So we need the rate of change. It's either 30 or 100, and then we need the units. So which one of these is initial value? 100. So this is the initial value. It's $100. So we know the rate of change is going to be $30, but we need one more unit. We've got dollars. We also need hours, so per hour. Okay, so the initial value is 100. That's the cost, right? So cost, this is a cost problem. So C equals, remember these things look like this, y equals mx plus b. So C equals the rate of change, or m, which is 30. And then for our x value, that's the number of hours. So let's say h, or n for number of hours, plus 100. Okay. We've done this a couple of times. I'm just going through it one more time here. Next one, I would like you to try this one. Okay, so pause it, try the question, and then unpause. All right, hopefully you did it. If you didn't, this is your last chance because I'm going to go through it. The rate of change is $1 per topping. The initial value, it costs $12 just for a regular old pizza. For an equation, it's cost again, so C equals 1. Let's do T for toppings, or N for number of toppings, plus the 12. Okay, so here we go. To write an equation, given words. Step 1, find the rate of change for a slope and initial value. So 2, the rate of change is m, initial value is b, the dependent variable is the y, the independent variable is the x. And remember, I think you're going to want to write this kind of everywhere, all over the place. Y equals mx plus b. And then, so the last step here is step 3, replace y, m, x, and b with the letters and numbers from the words. So again, pause it, copy that down if you need to, and then we'll move on to some graphs. All right, so we're asked to determine an equation again. Step 1, we need the initial value. So the initial value is b, So in this case, B equals $1,000. And now we need the rate of change. So we always use that point if we have it. I'm just going to pick one more point. And you might be thinking, well, there were a lot of points you missed. And that's true, but I want to show you something that works no matter what points you pick. So first we find the rise. So the rise is the height, or the change in height, from 1,000 up to this point, which is at 1,600. So we do the second value, 1,600, minus 1,000, and we get 600. And then for the run, we want to know the x value of this point, which I go down here at 6, and I subtract the x value of the first point, which is 0, and I get 6. And so the rate of change, or the slope, is always the rise over the run. I've written this so many times. I just want you to remember it. That's why I keep writing it. So 600 divided by 6, if I plug in the rise and the run, and that's going to be $100 per round, I guess. Number of rounds, it says at the bottom. Okay. So to do the equation, this is our y, right? This is our y-axis. So instead of y, we have c. So c equals, remember, it's y equals mx plus b. Our m is the rate of change, so 100. And then down here we have number of rounds. So little r, or little n. You might notice that the dependent variable is a big letter and the independent's a small letter. That's just the way it's done. It doesn't really matter. And then plus 1,000, because the initial value, or the b, is 1,000. So here's your steps to determine equation from a graph. Step 1, get the initial value, b value. It is where the line hits the y-axis. Step 2, get the rate of change, m. Find the rise and run between any 2 points, then divide rise over run. Step 3. So step 3 is going to be use the letters from the y and x axes as your variables. Plug in the letters and numbers into y equals, excuse me, y equals mx plus b. Okay, so again, we've done this. So that's why I'm going kind of fast, because I figured a lot of you probably don't want to watch this for a super long time. Excuse me. So there's the instructions for a graph. I just wrote that. I'm not sure why I have it again, so I will delete. I'll delete that slide. Last, from a table. Let's get in there. Here is a table of values. So first, when the x is 0, that's going to be our initial value. To get the rate of change, we find the rise. So we do this number minus the previous number, or we ask ourselves, to get from 50 to 150, how much did we go up? And the answer is $100. And this is probably going to be time in hours because it's an electrician. They wouldn't charge per minute, hopefully. And then to get the run, we look at the change in the x values, or in this case the time, the independent variable, all the same thing. We do the bottom value, 10, minus the previous value, 0, and we get 10. So the rate of change equals rate of change, rise, divided by run, equals 100, and that's dollars per hour. And this is our M. So when we're done, we have C equals, oh, it's not 100, right? 100 divided by 10 should have been 10. So $10 per hour. And if you can get an electrician for $10 an hour, you take it, because that is the deal of the century. So it's going to be C equals 10, and then this variable is time in hours, so I could say T, or I could say H, or N for number of hours. I'm going to say H for 10 times the number of hours, and then plus 50. So this electrician charges $50 to show up, plus $10 an hour, which again is insane. So maybe this is per minute, because then it would be $10 a minute, which would be $600 an hour, which that's too expensive now. Don't worry, sorry, I just made these numbers up. They're obviously not great, so don't worry too much about it. And now, to determine equation from a table of values, I'm going to copy this, paste it, and then I'm just going to make a couple of changes, because I want you to see how similar these are. So step one, get the initial value B. It is where, let's say it is the Y value when X equals 0. And that's what we did. Get the rate of change. Find the rise and run between any 2 points. Well, that's pretty much the same, but I'm going to say between any 2 rows, not toes, rows in the table. Again, so similar. Use the letters from the Y and X axes, but instead I'm going to say use the letter from the Y and X columns in the table as your variables, plug in the letters, and you're done. Okay. So again, this is a bit of a recap, so if I went too fast, you can slow down the playback speed in YouTube if you click the 3 dots, or you can speed it up if I'm going too slow. Okay, so if I look at what I gave you, we're through the first 2 pages, and then we've got 3 graphs and 4 tables. So I'm going to do 1 graph and 2 tables and leave the rest as homework. So here we go. I want to make this page width. All right, independent variable. The independent variable will be red, and it's always down here, so time. The dependent variable will be blue. It's always over here, so it's going to be amount owed. The initial value will be green, and it's where the line crosses the y-axis. So this looks like 100, 200, that'll be $900. The rate of change will be purple, and that's the hard one. So to do the rate of change, let's just pick any 2 points. So I'll pick this one, and it doesn't really matter. I'll pick this one. So to get the rise, we do the y value of this point, the point on the right, so 600, minus the y value of the first point, which is 900, which is negative 300. And then the run, we do the x value of the point on the right, which is 2, minus the x value of the point on the left, which is 0. We get 2. So the rate of change equals negative 300 divided by 2 equals negative 150. So my rate of change is negative $150. Remember, the rate of change needs 2 variables, so negative $150 per month. So that means this person's loan is going down by $150 per month, and it looks like after 6 months they've repaid the loan and they owe 0. Okay, now for the equation. Instead of y, amount owed. So I'll say A, amount equals rate of change. Remember, as always, y equals mx plus b. So this is b, this is m. So negative 150, x is time in months, so let's say m for number of months. You could use n or t, I don't care. Try to use lowercase. And then plus b, which is plus 900. Okay, so that's how you do that. I would like you to try this one and this one. Pretty much the same thing, right? It's all the same stuff. Let's do a table. So we're going to find the equation. So first, when x is 0, this is my initial value. To get the rate of change, I do the rise, and I do the number below, minus the number above, and I get 3. To get the run, I do the x values. This is the x's, this is the y's. I do the number below minus the number above, and I get 10. So my rate of change equals 3 divided by 10, which is 0.3. And the units are dollars per kilometer. Or I could say 0.30 per kilometer, because that's 30 cents. So you get in a taxi cab, it looks like it's $3.50 to start, and then 30 cents per kilometer. So my equation is going to be, instead of, remember it's y equals mx plus b, this is my m. My y comes from here, so c equals m is 0.30. Remember, I don't put units in equations. And then x is going to be d for distance, or k for kilometer. I'll do k, or little n for number of kilometers. And then plus b, my initial value is 350. Okay, so I did that one. I want you to do this one. And I'm going to do this one. I'm going to do one more. Okay? Step 1, my initial value is, oh, well, that's not 0. Huh. We got a little work to do here. Let's skip the initial value. It's too hard. This is my x's, this is my y's. So to get the rate of change, I do the rise. So 675 minus 475 is 200. And I do my run. 60 minus 40 is 20. So the rate of change is rise divided by run. I think that's going to be 10. I made a mistake there and I fixed it. So this is going to be $10 because it's cost per person. And now for the hard part. We need the initial value. So this is going up by 20 if we go down. So if we go this way, it goes down by 20. So it'll go 20. And then from 20, if we go down, we get it to 0. And then over here, it's going up by 200. So if we go backwards, it's going to go down by 200. So down 200 from 475 is 275. Down another 200 from 275 would be 75. So that means that this is my initial value, or my b. Equations always look like y equals mx plus b. In this case, our y is cost, so c equals, remember this is our m, the rate of change, so 10. X is the number of people, so I'll say little n, and b is the initial value, so 75. Okay, so I did this one where you don't have the initial value, you got to figure it out. I want you to do this one where you don't have the initial value and you have to figure it out. This one's a little bit trickier. If you can do this question, you are good to go with most stuff from the last several days at least. Okay, folks, do not hesitate to reach out to me for help. Our class has a very low level of participation, and that's very concerning because you're all moving on to grade 10, assuming you pass this course. And if you haven't been doing any of this stuff, grade 10 is going to be really, really hard. So please reach out to your friends in the class or people that you even know in the class and just tell them, you know, get on there, watch the lessons, do the little bit of work that's there. I mean, a lot of you have the time. Some of you might be working, helping around the house. I get that. But take the time that you have, because this stuff does matter in that you need it for next year. And it would be nice to have a nice grade on your report card this year as well. But more importantly, this is setting you up for success when we're all back in school, whether that's in June or September or whatever. I don't really know what's going to happen. Every couple of days they seem to extend the sort of quarantine, self-isolation measures. So I can't wait to see you all again. Until then, email me if you have questions. I can give you a call, work through stuff, whatever works. Okay, folks, good luck with those questions. And I believe that's your only homework. Yep, you've got 2 graphs to find the equation and 2 tables. All right, thanks, folks.